The last time we looked at this, we looked at a non-inverting amplifier, which we use as a preamp. So this is usually something that we use after a microphone and before a big amplifying system, and it takes a very little signal and it makes it into a more usable signal. We're looking at this non-inverting amplifier. Now this is significant. This means it doesn't invert the signal. So when you go high here, it goes high at the top, and when it goes low here, it goes low at the bottom. The second type of amplifier that we use is called an inverting amplifier, and we use it as a power amp. So I'm going to go through that at the moment. So this would be the graph of the input for an inverting amplifier or a power amplifier. So this is something that you could use with a guitar, or you could use after a preamplifier. Now if you remember, with the non-inverting amplifier, the first thing we do is find out where it's crossing the axes. So the frequency of this signal is going to stay the same, and I'm going to find out where it crosses the axes here, and I'm going to mark them on my graph because I'm going to try and work out what the V out is. And if we look here, I've got a peak here of 1, and then it goes down to -1. I've got a gain of 100, so that I know that my output should be the peak of the V in, which is 1, times the gain, which is 100. So my output should be 100. And if I look down here, I've adjusted the scale of this axis so that I've got 25, 50, 75 and 100. So I know it will fit onto this graph nice and easily. I know that the frequency stays the same, but this is an inverting amplifier. So what that means for the signal is that it does the opposite. It's got an opposite gain. It's got a negative gain usually. So realistically, it should say here that the gain is -100. For an inverting amplifier, the gain is usually a minus number. That means that when I work this out, really, that the output is 1 times 100. It's 1 times -100, so it's -100. So when it's 1 here, it's going to be -100 here. When it's -1 here, it's going to be -1, which is a double minus, which means it's a plus. It'd be +100. So an inverting amplifier, what it does is it changes the signal. It flips it upside down. It still does the big amplification that we want, but it actually flips the signal upside down. So here where I've got 1, it's going to go down to -100. Here where I've got -1, it's going to go to +100, etc. So I can work this out down here. I can put all the components in, and then I can draw my signal. So if I'm doing this through all the points that I've marked out, I can see that the frequency still stays the same. It still crosses the axes at exactly the same place, but when it reaches a peak here, it's going to a trough at this point here. When it reaches a peak on the output, it's actually a trough on the input. So it's doing the same as a non-inverting amplifier was. It's just flipping the signal upside down.